Uranus will be the most remote object visited by a spacecraft. It's so remote, in fact, it wasn't even discovered until just over 200 years ago. Whether there's been enough melting so that if there was rock inside, if there's not enough melting, the rock could be well distributed. If the water ice melts, then the rock will sink, forming a core. We have rolled the space. Here's a stellar occultation. We observe the starlight, measuring it every 100 times a second as the star is observed through the rings, and that will allow...
Could Uranus be a one-way ticket? NASA's only close look at this distant world suggests something far more dangerous than expected. When Voyager 2 flew past in 1986, it recorded radiation levels so extreme they puzzled scientists for decades, raising questions we still haven't answered. Amy Simon, NASA planetary scientist, once said, "Uranus is the real pale blue dot." And today, we are going to understand exactly what that means. Picture a world nearly 19 times farther from the Sun than Earth. Uranus, the seventh planet, is an ice giant about 4 times wider than our planet. Discovered in 1781, it stands out for one major reason: it spins on its side, with a tilt of almost 98 degrees. This extreme tilt creates one of the strangest seasonal systems in the solar system. One pole faces continuous sunlight for 42 years, while the other remains in darkness for just as long. Surrounding this tilted planet are thin, dark rings and dozens of moons locked in complex orbits. Its atmosphere is brutally cold, dropping near 370 degrees EF, yet powerful winds race through its clouds at incredible speeds. When Voyager 2 finally reached Uranus in 1986, scientists expected a quiet, frozen world, but what they found was far more complex. Voyager 2 remains the only spacecraft to ever visit Uranus, passing about 50,000 miles above its cloud tops. It sent back the first detailed images of this pale blue planet. One of the first surprises was the discovery of new rings and multiple previously unknown moons. Instead of a simple system, Uranus revealed a tightly packed and chaotic environment where moons and rings interact constantly. But the real shock came from the radiation data. Voyager detected an unexpectedly powerful radiation belt surrounding the planet, far stronger than scientists had predicted. These readings didn't make sense at the time and remained unexplained for years. Even more puzzling was Uranus's magnetic field. Unlike most planets, it is both tilted and offset from the center, creating an unstable and constantly shifting magnetosphere. During its flyby, Voyager even passed through a massive magnetic bubble, releasing charged particles into space. The moons added another layer of mystery. Miranda, one of Uranus's smallest major moons, showed deep canyons and a fractured surface, suggesting it may have been shattered and reassembled long ago. Uranus holds the record as the coldest planet in the solar system. Its upper atmosphere reaches temperatures lower than even Neptune. What makes this even stranger is that Uranus produces almost no internal heat. Unlike other giant planets, it does not radiate significant energy from its core, making its interior unusually quiet. For a long time, Uranus appeared calm and featureless. But more recent observations have revealed storms and sudden changes in its atmosphere. Despite the cold, winds can reach extreme speeds, pushing clouds rapidly across the planet. Its extreme tilt also drives dramatic seasonal shifts, where sunlight and darkness dominate each hemisphere for decades at a time. Uranus is surrounded by narrow, dark rings that reflect very little light, making them difficult to observe. Its moons form one of the most complex systems in the solar system, constantly interacting with each other and with the rings. Some moons show signs of past geological activity, including deep fractures and reshaped surfaces. Others may even hide subsurface oceans beneath thick layers of ice. New discoveries continue to reveal how dynamic and unpredictable this system really is, challenging earlier assumptions that Uranus was a quiet, inactive world. Since Voyager 2, no spacecraft has returned to Uranus. Today, scientists consider it one of the highest priorities for future exploration. Many questions remain unanswered, including why it spins on its side, why it lacks internal heat, and how its strange magnetic field works. Studying Uranus is also important beyond our solar system. Many planets discovered around other stars are similar in size and composition, making Uranus a key to understanding them. A future mission could finally reveal what lies beneath its clouds and solve mysteries that have remained unanswered for decades. Uranus proves that even the most distant planets are full of surprises. Its strange structure, extreme environment, and hidden complexity challenge everything we expect from a planet. Understanding Uranus could unlock deeper insights into how planets form and evolve across the universe. If you found this video interesting, make sure to like, subscribe, and comment for more.